All right, so let's get into acyclic heart data and how to get it out of our AXL HART I/O modules. One way to get acyclic heart information from the AXL I/O modules is to use function blocks, heart function blocks available in PLC Next Engineer. So again, these are for reading and writing heart commands to connected heart sensors. Fair warning, this is a bit complex here, so this is not going to be for every user. But if you have heart devices connected to AXL I/O, whether it be on AXL F, AXL P, whether it's next to a bus coupler in Profinet or on a PLC Next 252, you can utilize heart function blocks in PLC Next Engineer to actually read and write to that heart sensor. So let's get into it. All right, so the first thing that we're going to need is the libraries for PLC Next Engineer. You can simply go to the PLC Next store and type in, AXL HART, and here we go. We see a few different options here. So we're going to need two libraries. We're going to need this AXL HART library, and we're going to need the Acyclic library. So we're going to grab this AXL HART library, download it, and install it. We're also, like I said, going to need Acyclic. I see here as the data I'm recording, version 9 is the only one that's available, but we are going to need version 10. So just keep that in mind, that if you're looking at this video later, you're going to want to look at Acyclic version 10. It's just not available in the PLC Next store at the time of recording. So once you've got those two libraries, you're going to want to install them. So, over here, add user library, we see here Acyclic 10 and AXL HART 2. These, again, are the two libraries you're going to need. Once they're installed, you're going to have access to a lot of different function blocks here. So for Acyclic, we're going to need the actual, AXL communication, or the synchronization function block for the AXL local bus, and as well for Profinet. And then for the heart libraries, we're going to want the AXL HART communication function block. So I'm not going to build it up from scratch in this video because it does take a terribly long time. But I have it all set up here in this program. So first things first, we're going to look at the local bus. So the AXL F local bus, when a heart module is connected to the PLC Next. So when we have a heart I/O module, AXL F AI8, for example, connected directly on the AXL F local bus to the PLC 2152, for example, these are the function blocks and these are the tools you're going to need. So I'm going to go through each component in this program and explain how it works, and then we're going to go through a quick demonstration. So first things first, we're going to need to synchronize the data structure. We're going to need to synchronize the information, the structure that contains the actual heart module and information. So we're going to use this Acyclic AXL, and all you need to do is put in the slot, sub-slot information, and then the structure. So the slot information here, this is asking which slot it's in, which physical slot it's located in. If you're confused as to which slot, you can look here on AXL F, and you can see under here, we see the slot number. So we see the AXL FA heart is in slot 7. We can also go to the actual local bus of the controller itself, and we can see here slot 7. So I've got smart elements in slots 1 through 6, and slot 7 here is my analog input heart module. So back to PLC Next Engineer, we know we're in slot 7, so we're going to have to put the number 7 here for slot. Sub slot we're always going to keep at 0. And then here is our structure. So you're going to just need to create a user data structure, call it whatever you want, and this is going to synchronize the communication. It's going to be just needed for these function blocks. So that's first up, this one. Next, we're going to go down to the heart communication block. So here's the actual main heart block of the system. It consists of, items on the input side being activate, which activates and turns on the function block. The channel number. So the channel number is, now that we know we're pointing at slot 7, what channel is the heart sensor on? It's an 8-channel device. If we go back in here, we can see here that I am using channel 1. I can go back to parameters and take a look a bit more clearly. Channel 1 has 4 to 20 milliamp enabled, and if I go to heart channels, we can see here channel 1 is enabled, everything else is disabled. So I have my heart sensor connected to channel 1. So we're going to want to, in our program, point the I channel to a value of 1, because that's where my heart sensor is located. If your heart sensor is on terminals, that represent channel 4, you're going to want to put the number 4 here. B command. So command here is the actual heart command. So it's a byte, and I've put here command 3 because I'm going to show reading command 3 and command 14 in the heart specification. If you know heart, you know that there's a lot of commands that you can read and write. So here's where you would type in your heart command in byte format. So we're going to get in the middle in a little bit. Here is command data length. So this field is for typing in the length of your data that would be in your command data. So if you're reading, you do not need to use these. If you're doing a heart read, a read command such as heart command 3, you don't need to leave. You can leave these blank. You don't need to touch them. If you're writing, you need to specify the length of your command and then the actual data in the command. So we're going to leave these blank because we're not using them for our heart read. And then lastly, we have an execute button here. So the execute is what actually sends the heart command down. So the function block must be activated, and then the execute must be executed to actually send the heart command down. We'll see some statuses over here, but once we get it done, then we know that the heart command has successfully been sent down. I've just added a selector block here, so I can have either a single request go through, or I can loop an auto execute, I call it, or periodically trigger the execute to continuously read or write a heart command at a given interval. The last two items here, we have we need a user data structure for the actual heart data. So the buffer, the heart buffer, the heart process values that are actually going to be passing through. This is that UDT heart data right here. And then of course we need our async com, which again is the same variable from up here. So this is utilizing the async com to synchronize the function blocks here, to synchronize the data. Again, back to here under UDT. So this is our buffer that we're making to actually read the heart data. So when we send data down here using these commands, or when we read data using these commands, it's going to go in this UDT heart data buffer here. So the last thing, this is pretty much it. This is all you need to perform these this acyclic function block heart command read and write. I've gone one step further, and with the help of Thilo Glass in Germany, he showed me how to create just a few decoder blocks, because if we just read this value right here, if we just put this in the watch window, it'll just be a bunch of bytes, and it'd be nice to actually decode some of those. So I've just made two function blocks here. I made a decoder block for command 3 and command 14. I'll open that up in a minute, but basically this is what the command 3 block looks like right here. It's simply got activate, and it has the heart data structure. So this is the data. This is the heart data that I'm either reading or writing from the heart sensor, and that data is going to be utilized by this decoder function block just to interpret the data. I'm going to be pulling heart command 3, which gives me the current, the loop current. It gives me the PV, SV, TV, QV, and all their units. Heart command 14 is over here. It's another block, and that's the one that gives you the upper and lower limits of the heart sensor, as well as the units. So this one is a read and write. So what we could do is we could write and change the upper limit or change the lower limit. In doing so, we would, put the command into this buffer right here, and we would send that array down, send that array of heart data down to command 14, and then that would change this. So let's open up just the function blocks for the decoders just for a moment so you can see what they're actually doing. Basically, it's just taking the standardized heart command 3 and just mapping the data. So the milliamp value from the heart, the PV value, the SV value, TV, it's all just located in the heart command 3 response in different sections. So bytes 1 to 4 are the milliamp value. So I just use a simple buff to real function block here, which is in, I believe, extended data handling buff to real. And so that buff to real, what that does is it just takes a buffer of bytes in this example, and it puts them into a destination. So I put it into a variable that's just a real, and that's the makeup of this function block. Just uses a bunch of these buff to reals. So we set the format to true based on big or little Indian. Our offset here is 0, and we want to pull 4 bytes. So there we go. We get bytes 1, 2, 3, and 4 from the user data structure array from the heart data, and we put it right there in the real. So we do that same process here, but for bytes 6 to 9 for the PV, for bytes 11 to 14 for the SV, etc. We can also pull the actual unit. If we pull the unit in this example is an index 5 for the PV. We just have to look up the identifier and the unit code. So if I go to the actual unit code method, we see here these are all the different identifiers for heart that give you the unit. So if we're doing Celsius here, it's going to give me unit code 32. This is really just interpreting that and saying, look up the unit code table, pull it is, okay, it's 32. Now that's the unit for the PV. And then we do the same thing for SV, TV, QV. And that's pretty much it. That's the decoder function block for command 3. For command 14, it's quite similar. We're just, pulling different bytes from different information. So we see here, we need to pull the upper limit, lower limit, and the unit. And we do so using these bytes 4 to 7, 8 to 11. And then the unit is in indice 4 in the array. So that is pretty much it for these function blocks. So these decoder function blocks are not included in the library. Maybe they'll be included in the future, but for now they are not included. Just made them individually here. So again, if I go back to heart command 3, go to variables, you can see the actual variables. So for the function block, for my inputs, I have an activate. That just activates the function block. My outputs are all of what we talked about before: PV, SV, TV, QV, loop current, and the units. My in-out is a UDT data, so the data structure that actually is, the heart data. And then the function blocks are again buff to real. So that's pretty much all you're going to need for the heart decoder function block command 3. For command 4, open that one up again. And we see here again, inputs, outputs, in-outs, function blocks. Once this is all set, you can again, you can make your function block like I did and just drag it in and it looks just like this. So this function block, we've put just a trigger or just a setup in here to make sure that it only executes when command 3 is being called. So if byte command 3 up here, if this B command is actually equal to 3, and the function block has finished a valid, heart read, then it's going to activate the function block and populate these values. Same as command 14, if the byte command, if the command number for the heart command is 14, and there's a successful done, it's going to execute the command. Last thing in this program is the loop timer. So I just made a really simple loop, which just toggles this value every 5 seconds or so. It turns it on and turns it off. And what that does here is to say I want every 5 seconds or so I want to execute this function block. So enough talking. Let's turn it on. Oh, actually, before we do that, we'll look at the variables here. So if I look at the async block here, again, we've got our function block itself, our slot, which is a word, again, slot 7 that we talked about before, subslot, keep that at 0, and then the async communication, the synchronous communication structure. Under heart, we've got the function block, we have to activate the channel number, which again, like I said, I'm using channel 1, but you could use any channel on the heart module. The command, I have a default to pulling a heart command 3. And then again, the length we're not using, and the command data we're not using because we're not writing, we're only reading, etc. And then we've got our decoder blocks. So let's go ahead and let's go online here, and we can actually execute the command, execute the function blocks. So while it's online, we see here that the async communication, all you need to provide it is the slot number of the local device, and the you're up and running. That's pretty much it. Under heart communication block, we can see all the default variables that we have set here, and we go down to our heart decoder. We see that this is all blank because we have not executed the heart function block. Just to look at this a bit more clearly, if we look at the actual heart, UDD heart data, and we pull that data structure into here, we can see here it has, the device information of the heart sensor, we have the header, and then we have the actual heart data. All this data is all zeros right now. Once we actually execute the command, it will populate. So, once everything is set up, you just simply activate the actual heart function block. And now the heart function block is on, and we see that it's active, is true, so it's ready to be used. Now we can simply click here, this execute. So what we can do is just turn on auto execute, that's what I do. And it's going to pull the function block. It's going to execute it, say it's busy, and then when it's done, it's going to populate down here. So our heart decoder block for command 3 is executing every time that there's a successful heart read, and it's populating, our loop current PV, SV, TV, QV with all the units successfully. If we go down here to the actual heart data, we can see the actual array now is being populated. So again, what's going on here is this heart function block right here is executing. It is utilizing the path, the tunnel of the heart module, and it is sending a read request, a command read for reading command 3, and it's pulling that module and saying, give me whatever is in slot 7, which is the heart module, give me whatever is in channel 1, and read command 3 from that heart sensor. And that's what it's doing. It's putting that information in this data structure, in this heart buffer here, and which is that data that we see down here in the watch window. And then what I'm doing additionally is interpreting that data using a decoder function block. So if we go ahead and change this from command 3 to command 14, in hex is 0E, we're going to go see here that command 14 is going to now start pulling, and it's going to be reading the upper and lower limit. So we see here the upper limit and the lower limit, and the degrees Celsius, the unit of the sensor. And that's pretty much it. That is an example of how to use these read and write commands with these heart function blocks. I'm not going to do a write command because it just takes a while to do. But it's the same process here. You would populate the buffer, set your length, set your command, and then do a single request and just write that down. Like if you want to change the long tag, for example, of a heart sensor, you would write in ASCII your long tag, convert it to hex, put it in the command data, send it down one time, and then maybe even read it back just to confirm. But that is it. That is acyclic heart communication using these function blocks. You're able to read and write really detailed, really specific heart information. You have access to any heart command in the specification, and you can pull all of this data from the heart sensor into your PLC. Now, all of this was for when you have a heart module on the local bus of a PLC. When you have it behind a Profinet bus coupler, for example, it's very similar with just a slight change. So the only change is, let's use, I've got, Profinet bus couplers here for Acyclic line F and Acyclic line P. Let's use the Acyclic line F one. So I have another AI8 module. This one's intrinsically safe, but it doesn't matter. Also configured the same way, where I have channel 1, I have a heart sensor connected, and I'm pulling PV, SV, TV, QV loop current cyclically. I want to get that information, or maybe even more information, through acyclic function blocks. So I have another program over here, and this is doing the same process, but through Profinet, through a Profinet bus coupler instead of directly on the local bus. So again, we previously did it all directly here on the local bus. Now I'm doing it through a Profinet bus coupler. So the only difference here that you have is you have to use a different async com function block. So if I open up the other program here, we had to use async com axial line because it's an axial line local IO module. But instead, we're going to use this other function block here. Go to async com. We're going to use this one, async com pn. So async com pn is our function block, and the difference, instead of using a slot, instead of saying this is in slot 2 or slot 7, etc., we're just going to need the node ID. That's pretty much the only difference. You have node ID, and then you have your async com user data structure. So just as we did before, we also have a busy flag here, a Boolean variable right there. So the node ID. If you don't know where the node ID, it is if you double click on the slot, not the actual module itself, but the parent module here, and you go to sub module list. It's right here, 19. So that is the node ID. If I wanted to do the node ID for the Acyclic line P heart module here, or even the analog output module here, this heart one, I would go here and double click on that, and it would give me submodule list, and I would say node ID 27. So really all you need to do is enter that node ID 19 into, close this out, into right here. Once you enter node ID 19, the async com will look only for that node ID, and it will point these function blocks directly towards that IO module. Same as before, you need to enter the channel information, so channel 1 in my scenario, byte command 3, etc. All right, that's enough. Let's go online and look at it. So again, this is 19. DW node ID is 19, which is in hex, it looks like 13. So we've entered 19 in there, it shows up as 13. Now it's pointing directly to here. Same as before, we're just going to turn the function block on, and then we're going to go ahead and execute command 3. And what's going to do is going to execute command 3. Once it works successfully, we're going to see here this function block down here populate. Very good. So now we see current, loop current, PV, SV, 2V, QV, and the units. Again, this is information that we already have. The command 3 information, we already have that in the cyclic data exchange. We've already got all of that right here. Oops. So this is just showing, how to get it a different way, but heart command 3 is probably not the one that you're going to use all the time if you're using these function blocks. it's just an example. It's just proving out that you can do any heart command through this process and get reading and writing loads of data and a lot of information from your heart sensors. One thing that's really nice about this setup here is, let's say for an example, you have 8 heart sensors. You have an analog input module, 8 channel, right? Just like this one, but you have 8 sensors. If you connect all 8 sensors to all 8 channels, you only have 8 slots available for your process data, your primary values. So you won't be able to go ahead and do PV, SV, TV, QV, loop current for all 8 because you only have 8 slots. So if you have 8 sensors connected to one I/O module and you want to get more than just one process variable in the cyclic data exchange, you could then go ahead and do this. You use the function block. You simply say, point me into channel 1, point me into channel 1, my one heart sensor, and just give me command 3. And it will be slower. It will definitely be slower. It's not going to be cyclic, but you can pull all of the heart PV, SV, TV, QV loop current directly with just one heart command. So that's the advantage here. Using these function blocks allows you to get a lot more data, slowly, but a lot more data from the heart sensor. It also allows you to parameterize the heart sensor if you want to write the information down, like I was saying before, with a long tag, for example, or other heart commands that allow you to parameterize or configure the heart sensor. So this is pretty huge. And this is a way to, through a Profinet bus coupler or through a local I/O module, a way to read, write heart acyclic information through our Acyclic HART modules. We've got analog input and analog outputs for Acyclic F and Acyclic P. So that's pretty much it. That's the acyclic configuration with function blocks.